Okay, moving on to question 4. So this question is definitely probably one of the trickiest questions on the exam and relatively challenging. So if you found this particularly confusing or hard to do, just know that you are not alone. But we'll go through it together, and hopefully this walkthrough makes things make more sense. Okay, let's just start off with the prompt. So it's saying, in the table on the following page, the expression column gives different expressions that could replace the comments in the calls to system.out.print in the animal and bee classes. Fill in the prints column with the value these statements would print when filled with the indicated expressions. Okay, so let's look at this table on the next page. We have comments, expression that's going to fill in the place of this comment, and then what's printed out. So for the first row, in place of the comment A, we would put the expression X. So if we go back up here, we'd put, in place of this, would put an X, and then we'd see what gets printed out. Sometimes a given print statement will only be reached for certain replacements of other comments. In those situations, consider only the cases where the print statement is actually reached. Okay, so if print statements, if reaching a certain print statement depended on other print statements, then we're only considering the case where the print statement is actually reached. We'll see that this case doesn't actually really happen in this problem. The last line is when an answer differs depending on what expressions go into other print statements, indicate this with a question mark. So yeah, if there's basically multiple answers that could occur, then you would put a question mark instead of one answer. Although again, this case also does not occur, but we'll see it. And then note there are no compilation or runtime errors, so we can assume that every expression here listed in the table is going to work. Okay, so basically what this question is testing is your knowledge of dynamic method selection in addition to accessing instance variables, and static methods. So as you can see in the animal class, we have an instance variable, static variable, an instance method, and a static method. So let's just do a quick review of how accessing this works so that the problem makes a bit more sense. Okay, so dynamic method selection. We've talked a lot about how you can override instance methods. So say I had class A with the method X. This extends at some point, or B is a child class of A, and it also has a method called X. Then this method overrides the method in class A. So yeah, you inherit the method, but you can also override it. Now, how do you determine what method you're going to end up running? There's two checks. First is compile time. We check if the method exists in the static class. So in this case, if I called var.y, then I check if the method y exists in the class A or any of A's superclasses. Now, if it does, I continue to runtime, and in runtime, I find the method to run starting in the dynamic class. So in this example, I would start looking for the method y in the class B, and then move my way up to B's superclasses. Okay, and then also note that the method we run at runtime has to match the signature we found at compile time. Now let's talk about, so that's instance methods. What about instance variables, or static methods? In this case, we never override these attributes of a class. What actually happens is they're hidden. So let me write some examples. So say I have int x equals 5, static int y equals 6, static int z. This is a function. So these are defined in class A. Class B, since it's a subclass of A, it will inherit those attributes, but you could also redefine them. And if I use the exact same names, what happens is this redefinition hides the values that were defined in the superclass, but it doesn't overwrite them. Basically, both versions are still active and could be accessed depending on whether like your variable static type is B or A. So if I do object.x, object.y, object.z, for determining which x, y, and z to actually access, we look for x, y, and z in the static type of object, or then its superclasses. So if object had static type A, then object.x would refer to 5. But if object had static type B, then it would refer, oops, I should make these different numbers. Let me change this. So let me change the x in class B to 15. Yeah, so if object had static type B, then it would refer to 15 instead of 5. And then the last thing to know is this. So this .x, the same exact rules apply that I just talked about. The key thing to note is that the static type of this is the class it's inside. So we'll see that very quickly on the problem. Okay, so let's actually go through this now. So the first row, we're replacing the comment A with x. So you can think of, instead of this A here, we're writing x. So what's going to print out? Or actually, before we jump right into that, let's read our code. So we have instance variable, static variable, instance method, static method, and another instance method. And then as you can see, the insect class, which is a subclass of animal, also redefines x and y. So this is going to be the method or the field hiding that we were talking about before. And then the B class also redefines the x and y. Also, the B class redefines f. Since this is an instance method, this redefinition is going to override the method f from the animal class. And it redefines the static method g. So for the static method, it's not going to override it. It's going to be static field hiding. Okay, now let's see what the question class is doing. We have a main method. In that method, we create a new B object. So this B has static and dynamic type of B. Then we pass it into this H function. So then when this B is passed into here, Q, R, and S will have static type animal, insect, and B, respectively, because of the types of the parameters. But since we passed in a B originally, they'll all have dynamic type B. So hopefully that makes sense. So now we can go back to what X will print. If I print out X, when I just have X alone in a class, you can also think of it equivalently as printing out this .x. And I think writing this in front of your attributes makes things a little bit more clear to parse. Because you can think, okay, what is the static type of this? Well, right now this is written within the animal class, so its static type is animal. So then when we're looking at what version of X to use, we're going to use the version that exists in the static type, which is animal, so we're going to look in the animal class for the X value, and that's going to be 1. So this will print out 1. Okay? So hopefully, let's put that out there. Hopefully that makes sense based off what we just talked about, accessing the instance variables and static variables of a class. Okay, now instead of X, if we had Y, it's the same situation, right? You can write Y as this dot Y, and that will make things clear. This has a static type of animal, so I'm going to look for the Y variable within the animal class, and that variable has a value of 2. So for the next row, that's going to be 2. So you may be thinking, okay, we did the sort of the exact same process with X and Y, but X was an instance variable, Y was a static variable. Like, what's the difference? Well, with instance variables, each new object, so each new bee or animal instance, has its own copy of the X variable. Whereas with this y, since it's static, all instances share that same copy. So in actuality, it's not good practice to just write y or this dot y, because then it can lead to confusion where the programmer thinks that it's an attribute of the instance, whereas to be perfectly clear, you should always write the class name and then the instance variable. So if we wrote animal.y instead, then that'd be very obvious that y is a static variable and we're accessing it, and it exists in the animal class. However, if we don't write animal.y and we do this.y, it still works. We just use the static type of this, which is what we did in this problem. Okay, let me erase some stuff. Okay, so let's move on to row 3. So row 3, we're still in comment A, and we're replacing it with this dot x. So now A is this dot x, and we literally just talked about this. Writing this dot x is the same thing as just writing x, so this is going to be a copy of what we did in row 1, so that's also 1. And then row 4, putting this dot y, same situation, it's the same thing as just putting y. We look at the static type, that's animal, so we're going to return 2. Okay, so the first 2 rows, we're doing the same thing as the second two rows. Okay, now what about this row here, where we cast this as an insect? Okay, so let me move that up here. So instead of A, if I cast this as an insect and then I access the x attribute, well, in this case, this is casted as insect, so this whole thing in front of the x now has static type of insect. Because that's what casting does. It temporarily changes the static type of a variable. So now when we're trying to see what version of x to actually use, we're going to look at the static type, which is insect. So we look in the insect class, and we see the value of x is 5. So for this one, we're going to be returning 5. And then if we do keep the cast, and instead of referencing x, we're referencing y. Similar situation, we look at the static type in front of the y, that's going to be insect. So we're accessing the static y from the insect class, which is 6. Okie dokie. So that is it for comment A. Let me erase all this stuff. Moving on to comment B, the first row asks us to replace it with y. So let's find where B is. Okay, here. Now I'm in the static method G and I replace this with y. So if I print this out, it's the same thing as we've been talking about before, as just saying this dot y. So then I'm just going to be accessing the y from the static type of this, and this is written in the animal class, so the static type would be animal. So I look in the animal class for the static variable y, which is 2, so then this prints out 2. Okay. Now if I do, instead of y, the next row asks us to write insect.y, so I'll fill that in. So this is how actually we should access static variables with the class name .variable, because it makes it much more clear. Now it tells you, okay, I'm looking at the insect class at the static variable y, insect class, static variable y is 6. Awesome. So that's it for the comment B. Now the next lines asks us to go to comment C, and the first one is what's Q.F going to print. Okay. So comment C, Q.F. Okay, so as a reminder, the static type of Q is animal, because when we passed it in, the parameter here is type animal, so it takes on static type animal. However, the dynamic type is going to be B, because it actually is a B, as we defined it in the main method. Okay, so now we can actually use our dynamic method selection that we were talking about earlier. The first step is compile time. We check if the method exists in the static class. So we're going to check if this method f exists in the static type of animal. So we're going to look in the animal class for a method called f, and boom, we've found it. So the compile time check is all good. Now at runtime, we start looking for the method f from the dynamic class. So we'll see if f exists in the B class, and it does. So we're going to go ahead and run this method here. So, and that method returns 11. So this line here, the print is going to print out 11. So that is 11 for this line. Okay, what about the same thing, but for r.f? So I've had R. So R also has dynamic type B, because I passed in all the same things, but it now has static type of insect. Okay, so let's do our dynamic method selection. We'll see if the method f exists in the insect class. And it's not written out in the insect class, but since insect extends animal, insect inherits all of the attributes of animal that are non-private. So I'm going to inherit the method f. So yes, the method exists in the static type. So now I go ahead and run it, starting from the dynamic type, which is B. So look at the B class for the method f, and that exists. So I'm going to go ahead and run this version. This is where we saw like the overriding. So I'm going to go ahead and return 11. Okay, lastly, we have this line where I cast animal s to animal, and then I call f. Let me write that out. So I'm casting s to animal and then calling f. So then this thing is going to have static type of animal because I casted s to animal. And then it's still going to have dynamic type B because it was a B. Casting only temporarily changes the static type. It never changes the dynamic type. Okay, so I can just go ahead and run my same old method selection. I check the static type to see if the f method exists. It does. And then when I go ahead and run it, I look starting at the dynamic type. So I'm going to look in class B. The method f exists here, so I'm going to run this version. So this is also going to return 11. Awesome. Now the question may arise, like, why are we casting? Like, did we need to cast? And the answer is no. If we just did s.f, that would have also like compiled and run fine because we look in the static type of s, which would be b for the method f, and that exists. So this is just testing whether you understand how casting works. Okay. Last thing in C is casting s to animal and then accessing x. So write that out. Okay, so back to accessing instance variables. Here I am looking at the static type before the x to see like which version of x to use, and the static type is animal. So I'm going to look in the animal class for my x variable, which has a value of 1. So then this is going to return 1. Awesome. Okay, moving on to the last comment. We're almost done. D we call super.f. So where is D? Here we are. Instead of here, we call super.f. Okay, so here we're in the B class, and we overrode the method f. To access the method f in our superclass, which is an animal, we can call super.f. So that's what we're going to do. Here, we're going to run this version of f, and that's going to return 3. So then this function here is going to print out 3. So yeah, you can basically access your methods or attributes that you overrode or hid using the super keyword. So for example, if you wanted to access the x that exists in our parent class, you could do super.x, and that would access the x in our parent class rather than this x here. So similar to how we did super.f. Okay, in D, if you just put x alone, let's see what happens. So we just put x alone. As we've talked about before, we can write this as this.x. The static type of this is now b, because this is written inside the b class. So we're going to look for the variable x inside the b class, and that variable has a value of 8. Awesome. So then this would print out 8. Okay, last line. Woo! Almost there. Animal, cast this to animal, then call G. Okay. Okay, so this has a static type of B, but I'm casting it up to animal, completely valid. So now, like everything before the accessing G, this has static type animal. So when I call the method G is a static method, so there's no dynamic method selection. I just use the version of the method that exists in the static type. So I'm going to call the method G that exists in the class animal. So that's here. So that's going to return 4. Yeah. So this is actually tricky. Like when I first did this, I totally just like forgot that this said static, and I was like, okay, dynamic method selection. Even if you cast it as animal, the dynamic type would be B. So I'm going to run this version, but you have to remember that it is static. So there's no dynamic method selection. You just run the version that exists in the static type. Okay, that is it. Hopefully that makes more sense. Yeah. How do I end this recording?